Welcome to True Projects. In this video, we are going to explain about the project title Stock Market Prediction Using Deep Learning. The Efficient Market Hypothesis (EMH) has long maintained that it is impossible to accurately predict the stock market because of the larger number of factors and the influence of human sentiments on stock values. Contrary to this, investors like Warren Buffett has repeatedly outperformed the market by using emotions and market inefficiencies. Initially, stock price predictions were made using conventional statistical techniques like linear regression and ARIMA. But as machine learning has become more prevalent, we have looked into techniques like genetic algorithms and artificial neural networks. The project focuses on using neural networks and deep LSTM long short-term memory to predict the stock market. The project's goal is to create a predictive model for the current and future stock markets using deep learning LSTM. Comparing the proposed model's performance against experimental findings from different deep learning methods allows for the evaluation of the model's efficacy. 11 LSTM layers make up the deep learning model's architectural structure and ADAM optimization tools are selected. In order to increase the performance of the forecasting model, the network is evaluated using various iterations and epochs. The experimental findings show that the deep LSTM model has the greatest accuracy values when compared to the others, demonstrating its applicability for precise stock market time series prediction. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of Wi-Fi and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, we import the necessary Python libraries and packages that will be used throughout the project. Common libraries for stock market prediction project using deep learning might include NumPy for numerical operations and data manipulation, Pandas for data handling and manipulation, Matplotlib or Seaborn for data visualization, Scikit-learn for machine learning tasks like data pre-processing and evaluation metrics, TensorFlow or PyTorch, deep learning frameworks for building and training neural networks, Keras, a high-level API that works on top of TensorFlow or PyTorch for building neural networks. Other specific libraries for financial data handling such as YFinance or Alpha Vantage for fetching stock data. Second module is data exploration. This module focuses on understanding and gaining insights from the historical stock market data that will be used for training and testing the model. Key steps in data exploration include loading historical stock price data, visualizing stock price trends, volume, and other relevant features, calculating summary statistics such as mean, standard deviation, and correlations, identifying any missing data or outliers, exploring the relationship between stock prices and potential predictor variables such as news sentiment, economic indicators, or technical indicators. Third module is data processing. In this module, we pre-process and clean the data to prepare it for training a deep learning model. Data processing steps include handling missing values, which can involve imputation or removal, feature engineering, creating new features or transforming existing ones that might be more informative for the predictive task, normalizing or scaling the data to ensure that all features have the same scale, splitting the data into input features and target variables, that is predicting the next day's stock price based on previous day data, creating training, validation and test data sets to evaluate the model's performance. Fourth module is splitting the model into train and test. This module involves splitting the pre-processed data into two or more sets. Training data set used to train the deep learning model. It contains historical data that the model will learn from. Validation set used to tune hyperparameters and monitor the model's performance during training. It helps prevent overfitting. Test data set used to evaluate the model's performance on unseen data after training. It provides an estimate of how well the model will generalize to real-world data. Fifth module is building the model. This module involves designing and constructing the predictive model itself. It encompasses choosing the appropriate architecture, defining model layers, and configuring hyperparameters. In deep learning, we might use neural networks, convolutional neural networks, recurrent neural networks, or other deep learning architectures. In this, we have different algorithms. Autoregression model. Autoregression models such as AR, P models are statistical methods that use a linear combination of past observations to predict future values. The parameter P determines how many past observations are considered. ARIMA model. Autoregressive integrated moving average. ARIMA is a popular time series forecasting model that combines autoregressive AR and moving average MA components. It also involves differencing to make the time series stationary. ARIMA models are effective for modeling and forecasting time series data with trends in seasonality. SARIMA model. Seasonal ARIMA. SARIMA extends the ARIMA model by incorporating seasonal components to account for seasonality in the time series data. It includes additional parameters for seasonal lags. Exponential smoothing. Exponential smoothing methods like halt winters are used to forecast time series data by assigning exponentially decreasing weights to past observations. These models are effective for capturing trends in seasonality in the data. Profit model. Profit is a forecasting tool developed by Facebook that is particularly useful for time series data with strong seasonal patterns and holidays. It can handle missing data and outliers and provides a straightforward interface for time series forecasting. LSTM, long short term memory. LSTM is a type of recurrent neural network RNN designed to handle sequence and time series data. LSTMs are capable of capturing long-term dependencies in the data and are commonly used for time series prediction tasks. XGBoost model. XGBoost is a gradient boosting algorithm that can be used for both regression and classification tasks. While not a deep learning algorithm itself, it is a powerful ensemble method that can capture complex relationships in time series data. Deep AR. Deep AR is a deep learning based probabilistic forecasting model developed by Amazon. It uses recurrent neural network RNN to model time series data and can capture uncertainty in predictions, making it suitable for financial forecasting tasks. And the fifth module is training the model. This phase involves using historical data to train choosing machine learning or deep learning model. It includes feeding the model with features and target variables, optimizing model parameters, and adjusting hyperparameters to improve its performance. The trained model will be used for making predictions. Sixth module is Flash framework localhost sign up and sign in with SQLite. Flash is a popular Python web framework for building web applications. In this module, we are setting up a web-based user interface for the stock market prediction using Flash. Some key components include localhost. This typically means running the web application on your localhost machine for development and testing. Sign up and sign in. Implementing user authentication features that allow users to create accounts, sign up, and log in securely, sign in. SQLite 3. SQLite is a lightweight database system. In this context, it's used to store user account information securely. User uploads the image for analysis. In this part of the project, we allow users to upload relevant data or images for analysis. In a stock market prediction context, users upload historical financial data or charts as images. Trained model is used for predicting user data. Once a user uploads data or an image, the trained machine learning or deep learning model is employed to make predictions based on that data. This can include predicting stock prices, trends, or other relevant financial indicators. Predict with model for outcome. This step involves feeding the user's data into the trained model and obtaining predictions or outcomes. Depending on the specific project goals, the outcome might be a prediction of future stock prices, buy or sell recommendations, or other financial insights. Display the final outcome. After making predictions with the model, the final results are displayed to the user. This can be in the form of interactive charts, textual summarizes, or any other user-friendly visualization. The user should be able to easily interpret and understand the predictions. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file. These model files, which contain algorithm information, will be loaded in the project code during runtime. This is notebook.main.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Open the Anaconda prompt. Use the cd command followed by a space and then paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address and port. So now copy the local link. I'm copying the link and paste this link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flash framework. So this is the homepage of the project. Now click on sign up button. If we are a new user, first we need to register. But I have already registered, so click on sign in. Enter the username and the password and click on sign in. So here we will enter the stock symbol, and after entering the stock symbol we will get the predicted price and the accuracy of prediction for the stock symbol. Now let us enter the stock symbol as ABBV and search. So here we got the predicted price and the accuracy of prediction for the stock symbol ABBV. So the predicted price is $114.36 and the accuracy of prediction is 97.5%. And here we can see we got two graphs. One is the real and prediction graph and other one is the loss and validation loss. So here on the x-axis we have days and on the y-axis we have the price. And the blue line represents the real and the orange line represents the prediction. And in this graph, here we can see the orange line represents the validation loss and the blue line represents the loss. Now let us enter one more stock symbol and get the predicted price and accuracy of prediction. So I'm entering the stock symbol as AAPL and click on search. So here we can see we got the predicted price and the accuracy of prediction, and here these are the two graphs, and this graph on x-axis we have days and on y-axis we have the price, and here the green line represents the real and orange line represents prediction. And here the green line represents loss and the orange line represents validation loss. Now click on prediction. Let us enter one more symbol. I'm entering TRIP, trip. Click on search. So this is the stock market prediction for TRIP. So we got the predicted price and the accuracy of prediction, and these are the two graphs. One is for real and prediction and the other one is loss and validation loss. So here we can see on the x-axis we have days and on y-axis we have the price, and the blue line represents real and the orange line represents prediction, and here the blue line represents loss and the orange line represents validation loss. So click on log out. So in this way, by entering the stock symbol, we can predict the price and the accuracy of prediction. The conclusion of the project is the suggested deep LSTM model exhibits promising outcomes in predicting the close price of stocks for the following day, utilizing historical stock price data from Yahoo's finance page. Performance measures including mean square error MSE, root mean square error RMSE, mean absolute percentage error MAPE, and accuracy are used to assess how well the model performs. The accuracy and performance of deep learning model are influenced by its architectural design, which includes 11 LSTM layers and ADAM optimization tools. According to the project's finding, the deep LSTM model can help traders and investors make wise judgments in the stock market.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.